So here we have how do we solve equations which are already in factor form. All the examples that you will see here today are already done in factor form. Factor form is whenever they're already inside the parentheses. Each factor is inside its own parentheses. So now, if we look at the first example, how do we solve equations which are already in this form? Well, in mathematics, there's a rule that says if two expressions are equal to 0, if you multiply two expressions, which in this we have x plus 2 times 3x minus 2 equal to 0, if you multiply them and they're equal to 0, so either one has to be equal to 0. So how do we express that? When two equations are multiplied and they're equal to 0, then we're going to set each expression equal to 0, and then we're going to solve individually. And this is how we solve equations which are already in factor form. So let's look at the left example with the next expression. How do we solve? U minus 2 to both sides. So now you have that x is equal to 2. This is one of my solutions. Minus 3. So minus x equals minus 3 divided by negative 1. So let's finish it off here. So we have that x is equal to 3. So in example number 1, we have two solutions. We have a solution when x is equal to minus 2 and x is equal to 3. Now, how do we know it makes sense? Well, let's plug it in. Let's plug in x to negative 2. If we plug it here, we have negative 2 plus 2, so this becomes 0. 0 times anything is 0, so that's why this is the solution. So let's plug in 3. 3 minus 3, that's 0. 0 times anything is 0. So we know that those two solutions fit in. So this is overall the scenario that we're going to be applying in every single example. Now, it doesn't matter we have 2 or 3 parentheses, they still follow the same rule. So let's look at example 2. You see 3 parentheses, or you see 3 expressions which are being multiplied. So what do? Well, if you want to solve, you set each expression equal to 0. Second expression, third expression, and then you solve individually. So let's solve the first. So minus 3. So now you have that x is equal to minus 3 plus 2. And now you know that x is equal to 2 and minus 4. So x is equal to minus 4. So after all this, you have 3 solutions, which are when x equals to minus 3, when x equals to 2, and x equals to minus 4. So minus 4 here. Again, when you have expressions and they're all multiplied and they're equal to 0, you gotta set each one equal to 0. Now what happens if I plug in? Let's plug into negative 3, plug it in here, negative 3 plus 3, this is 0. 0 times anything multiply, it's 0, so we're okay. Plug in 2, plug it into here, we got 2 minus 2, this is 0. Any the expression times 0, it's 0. And the same will happen with minus 4. Plug it into here, minus 4 plus 4, this is 0. Multiply two things times 0, it's equal to 0. This is why it works. You just need one of those expressions to be equal to 0, so whenever you multiply everything, it's 0. Doesn't matter if the expressions are more complicated. Yeah, doesn't matter. You still do the same. You have two expressions, multiply, equals 0. Well, what do we do at this point? We set each expression equal to 0. 5x plus 3 equals 0. And then you solve it individually. Look at the last example. Plug into one solution there. Solve for the right. So minus 3. So now you got 5x equals to minus 3. divided by 5. Oops. So once you divide by 5, you're going to see that x is equal to negative 3 over 5, which means that we have two solutions. We have the solution when x equals to 2, and we have the solution to negative 3 over 5. Can you have fractions as your answers? Yes. We're not going to check this. You can double check it yourself, but it should be okay. You plug it in, and you will get 0. So now, let's move on to expressions which are a little more complicated, I would say. What happens if the expression has an exponent? Can we still follow the same rule? Yes. So, there's two ways to go about this. One of them is to set the whole expression equal to 0, which we have x minus 5 to the 4 is equal to 0, and then you will solve that, but we haven't seen examples where, what do we do when the exponent is 4? We have not seen examples like that, so let's do it the long way. That is, what does x minus 5 to the 4 mean? It means that we have x minus 5 4 times. Alright, so I just rewrote the expression. X to the 4 is 4 times x minus 5. You have a lot of parentheses and they're equal to 0. So what do? Well, you set them all equal to 0. But you see that they're all basically the same expression. So it's sufficient to just solve one of them. So 1. So x equals to 5. If you put all the expressions equal to 0, then you will have this expression that we start with. So in order to make the job shorter, I'm just going to solve for 1. And this is the only solution, because that's the only solution that will work. You can plug it anywhere. Now, so example 5. Just a little more tricky. Now, what do we do in these instances? We still follow the same procedure. Two expressions, and they're equal to 0. So what do? You set each one of them equal to 0. So now you have x squared minus 25 equal to 0. And you also have x squared minus 9 equals 0. And then we solve individually. Now you gotta remember from algebra 1, to solve equations to the second exponent, you first need the second exponent alone. So let's add 25. So 25 to both sides. And now I have that x squared is equal to 25. Now the question is, you just want x, you don't want x squared. So how do I get rid of this second exponent? Well, you take the square root. Take the square root to both sides, because your root is 2. And remember, when your exponent matches your root, they cancel out. So now we have that x is equal to, this is an error that a lot of students make. It's not just 5, it's plus or minus 5. When you take the square root as your last step, you have two solutions. You have the positive and the negative. So whenever you're solving and your last step is to take the square root, your solution has a plus or minus. Okay? So now we have two solutions here, which is x is equal to 5 and x is equal to negative 5. So now let's try to solve the other one. Do the same idea. Leave the square root alone first. So plus 9 plus 9. So now we have x squared equals to 9. And again, I need x. I don't need x squared. So I need to get rid of this x to the second exponent. So what should you do? Take the square root to both sides. They will cancel out. And now you have that x is equals to the square root of 9. Now, my last step in the solution was to take the square root, so it's a plus or minus, and the square root of 9 is 3, so plus or minus 3. So in this case, I don't have 1, I don't have 2, I don't have 3, but I have 4 solutions. So my solutions are when x is equal to 5, when x is equal to negative 5, when x is equal to 3, and when x is equal to negative 3. So I have 4 solutions here. You can double check yourself, plug in any of these in your original, and you will have 0. So now let's look at the last example here. Okay. Can we still apply the same procedure? Well, do you have two expressions multiplying equals 0? Yes. So when you have two expressions multiply equals 0, then you set each one of them equal to 0. So this is what we're going to be doing. 6. The first expression is equal to 0. Now my second expression is equal to 0. Okay, and now we solve it individually. Now you gotta remember from module 1 that this is a trinomial when the leading coefficient is 1. So in order for us to solve this, we need to factor it out. So I like to use the X method to factor stuff out like this. Now I'm looking for two numbers that if you multiply equals the last number, 6, and also if you add them up, it's 5. So what are two numbers that if you multiply gives you 6, and if you add them up gives you 5? Well, those two numbers are 3 and 2. So the original we can factor out as x plus 3, x plus 2 equal to 0. All I did, I just rewrote the original, and we're going to apply the same. So we have that x plus 3 equal to 0, and x plus 2 equal to 0. And now we solve individually. So minus 3. So x equals to minus 3. Oops, it's supposed to be a minus there. X equals to minus 3. Minus 2. Okay. So now you see that we have basically the same scenario on the right side. It's a trinomial where the leading coefficient is 1. So we need to factor this out. And for module 1, there's different methods. The method that I like to use is the X method, which says which two numbers, such as if you multiply them, gives you the last number, which is negative 12. So two numbers that if you multiply gives you negative 12, and if you add them up, gives you the middle number, which is just 1. Let's see, 3 and 4. Now you know that your multiplication is negative, so one of them has to be negative. I'm gonna set negative 3 because if you add them up, you have 4 minus 3, which is 1. If I would have set it up the other way, that would not give me 1. So two numbers that if you multiply gives me negative 12. Negative 3 times 4 does give you negative 12. If you add them up, it should give you 1. Negative 3 plus 4 does give me 1. So we're going to move on. And let's rewrite the original as x minus 3, x plus 4 equals 0. All I did, I rewrote the top equation as this form, and then we can apply the rule again. Two expressions equal to 0, set each one of them equal to 0. So plus 3 here. So x equals to 3. Minus 4 here. So x equals to 4, negative 4. So at the end of the day, we have 4 solutions. X is equals to minus 3. X is equals to minus 2. X is equals to 3. And x equals to negative 4. Okay. There's a lot of factoring that happened today. I will post some extra videos about how do we factor this. Look up on the video on the link. Now, next up, here's your entrance ticket. Make sure you turn this to works at the beginning of the class tomorrow. Take good notes, and I'll see you.